Today's YouTube is to provide you with a little bit of a map discussion as well as a list of the sites that I use when I actually present a map discussion. Now, many of you in this class probably had me for weather and climate, and you know that one of the things that I always do at the beginning of class is to give a map discussion and a weather forecast for the next couple of days. And this is one of the things that falls out when I teach a distance course, because I typically teach distance courses just during a 6-week summer session or a compressed 7-week fall session. And it's only during spring of 2025 that I taught a 15-week class online for meteorology. And I decided when I started teaching this class online in January that I still wanted to actually try and give map discussions so that we can continue with this process. During compressed sessions, I just don't have time, but during a full semester course, I do. Now, having said that, one of the problems with giving map discussions during fall semester, at least at the beginning, is that particularly here in the Midwest, the weather tends to be really, really boring, at least for the first half of the semester. Now, not every year is boring, but most years are. And by boring, what I mean is that we are very much out of severe weather season. We don't experience hurricanes here. It's too early for snow. And in fact, we go through long periods of time when the weather is pretty good. It's fairly fair, and we don't get much precipitation. So the weather tends to be pretty boring. I will give map discussions, and hopefully I'll be able to find something somewhere that's interesting. And we do have something interesting on the maps I'm going to be showing today. But things probably won't get interesting for us here in Ohio, climatologically speaking, until we get well into October and November, when our surface highs and lows tend to get a little bit stronger because the jet stream begins to work its way south. But until then, it kind of is going to be boring. And in fact, over the continental United States, for the maps I'm going to be showing today, there's very little going on other than a hurricane out in the Atlantic. So what I want to do really today, since the weather's boring, is just to provide a PowerPoint presentation that shows you the maps that I use in a map discussion, as well as to provide you with the links to the sites to these maps. Now, this is just a basic map discussion that I'm giving today that focuses entirely on the surface. As we begin to add more content in our class and we go to upper levels and we start to look at additional fields that are used to predict the weather, then our map discussions will become longer and more detailed, and we'll look at more maps and more fields. But today, this is kind of a map discussion that I would provide in weather and climate relatively late in the semester, probably around week 10 or so before we start talking about upper levels. So why don't we just get started? Basic discussion. What I really want you to get from this is not so much the weather for this particular discussion, because again, there's not much going on, but I want you to get a list of these links, these websites that I use. So here's our PowerPoint, and why don't we just get started? So I always start with a surface map. So the surface map contains station models and isobars, highs and lows, and fronts. Now, if you are taking this class, then you should have completed weather and climate or weather studies lab. Either way, you know what a station model is, and you should know what the numbers are that surround our station model circles. If you are familiar with station models and you remember us talking about this, but you're not quite sure about what the information is, then you need to go back either in your weather and climate notes, or you need to go into our textbook, which actually does have information about station models. Our textbook has, I don't know, close to 20 chapters in it. We covered 10 of them in our class. The early ones are kind of weather and climate chapters, so you can go right back in there and get some information about station models. Isobars, just to remind you, are lines of constant pressure. Highs and lows, you should be familiar with those. And fronts always extend from centers of low pressure. The blue lines with the triangles extending from them are cold fronts. I'm not even sure, I'm looking for a warm front. Here we go. The red line with the semicircles extending from them are warm fronts, and then the alternating red and blue are stationary fronts. Remember that the direction in which the symbols point indicates the direction of the movement of the front itself, where the stationary fronts aren't moving, they're stationary. Again, very little going on the map. and I'm actually going to be showing you a map discussion with information from August 20th, which I believe is the Wednesday before classes begin. And you can see the isobar pattern is very disorganized. We have a couple of weak fronts on the map. You can tell they're weak because there aren't even really much in the way of isobars passing through them. The big story on Wednesday the 20th was Hurricane Erin, which was a major hurricane out in the Atlantic Ocean. It never makes landfall. It grazes the East Coast, in particular just the outer banks of North Carolina, and then it heads back out to sea. But we'll see some pretty spectacular satellite imagery of Erin moving forward in this discussion. Here is the link to surface maps from the Weather Prediction Center and separatists of the National Center for Environmental Prediction, which is part of NOAA. And so here is our link. Now, once I show you the surface map and move on, I typically like to show radar imagery and then satellite imagery. So I get my radar imagery from the National Weather Service. And so to get a radar image of the United States and even a larger area, here's our link. So radar.weather.gov. And then what you're going to do is you're going to select your view right up here. And again, this is from the morning of the 20th of August, and there's very little going on. There is some organized precipitation over the mid-Atlantic and southern New England. So this is where we're going to focus our next couple of slides on. But you can select national view or you can select a local view. So you go to select view, and I'm going to start with national radar. And here's national radar, but I've zoomed in just on the northeast corner of the country, and you can see our radar shading right here. This is a base reflectivity image in base reflectivity mode, and you should all know this. Doppler radar is sending out pulses of microwave energy that are then being scattered back to the radar site. By the way, the radar site is just outside, again, it's a national radar, so it's a composite. There is no individual radar we're looking right here, but we're going to focus in on the Albany radar in a moment. But here are our reflectivities, which is a misnomer. Again, this is scattered signal back to the radar. We'll cover radar and satellite in great detail in Chapter 5, which is our first chapter of our semester. You can then go to local radar, and this is the Knox, New York local radar. It's right outside of Albany. You can see this little circle right here. And again, this is base reflectivity. Here are our intensities of our scattered signal back to the radar on the legend in the lower left-hand corner of our map. So we'll look at base reflectivity, and all of you should know that these reflectivities, the intensity of the reflectivity, is related to the rate at which precipitation is falling from the clouds. We can then take a look at radar in base velocity mode, which is right here, where green shading indicates movement toward the radar, red shading indicates movement away from the radar. Here's our radar located right outside of Albany, right here. Keep in mind that what base velocity does, and again, we'll talk about this in detail in my PowerPoint and my YouTube presentation for Chapter 5, is that what the radar is doing is it's actually looking for a phase shift in the frequency of the scattered energy back to the radar to determine whether the motion is toward or away from the radar. And this motion right here is given, I believe, in knots. So again, green is toward the radar, red is away from the radar. So this precipitation is essentially moving from southwest to northeast. All right, so there is our movement. Again, base velocity radar. Once I show base reflectivity and base velocity, I then move on to satellite imagery so we can get a look from above. Now, I get my satellite imagery from the NCAR RAP Real-Time Weather Data website. That's a mouthful. Here is the link to the website. You can look at a lot of stuff, by the way. I just look at satellite imagery, but you can see surface data, forecast maps from models, radar, upper air maps, and there's some help. So it's a lot here. I'm just going to focus on the satellite imagery. So what you're going to do once you get to this home page, this front page of the real-time weather data site, is you're going to click on the satellite link, and it'll bring you up to a map of the United States. Now, you can either take a look at satellite imagery of the entire United States, or you can click on any one of these regional links, and the site will just zoom in on that region if you really want to focus on what's going on satellite imagery over a particular region. And obviously, when I'm teaching class and there's something really interesting going on in some other part of the country, I almost always just click on the Detroit link so we can take a look at the Great Lakes region. Now, when I'm taking a look at satellite imagery and presenting in class, I typically will show visible satellite imagery with color versus grayscale. I'll also show infrared and the long wavelength and water vapor and mid-level water vapor. All right, so just take a look at these three images, and we're going to take a look at the contiguous United States in the examples I'm providing in this PowerPoint. And again, these come from the morning of August 20th of 2025. So here is our visible satellite image. Here it is, August 20th, 2025. Remember that when we're doing weather, when we're looking at meteorology, all of our times are in Z or Greenwich Mean Time. So this is 1417Z, so this would be 2:17 in the afternoon in Greenwich. And to get the time for Eastern Daylight Time, you would subtract 4 hours, and so this would be 10:17 in the morning. Here's Erin, a really, really beautiful satellite depiction of Erin with a nice, well-developed eye. You can see our precipitation that's probably falling from these clouds over upstate New York and southern New England. And we just have some overcast skies in Ohio at this particular time. And then much of the rest of the country is clear. If you take a look at the Rocky Mountains, a lot of this is actually snow cover over the Rockies, even in late summer. If we take a look at infrared imagery is basically telling us the amount of long wave or infrared energy that is being emitted by the highest surface over a location. So if there are no clouds, that highest location is the Earth's surface. If there are clouds, it's the amount of infrared that's being emitted by cloud tops. Remember from weather and climate that we can use Stefan Boltzmann law for a given temperature to determine the total amount of energy that is being emitted. And we can use Wien's law for a specific wavelength, which in this case is 11.2 micrometers, to determine the amount of energy that's being emitted just at that wavelength. The higher the cloud top, the colder the cloud top is, the less energy it will emit at this wavelength. And so we can use that amount of energy being emitted, we can use Stefan Boltzmann, and then calculate the actual temperature of the cloud top. And we get that from our legend right here. And again, where there is no cloud cover, you can see that the temperatures are between 20 and 40 degrees Celsius, so between basically about 68 and 104 degrees Fahrenheit. And anywhere there are clouds, you can see that these cloud tops are going to be relatively cold, and you can see very quickly that the temperatures go down. With Erin, particularly in the eye wall, right around the center of the eye, you can see that cloud top temperatures are colder than 60 below 0 Celsius, so obviously extremely, extremely cold. If we take a look at this on water vapor is another type of infrared image. We're just looking at a different wavelength of infrared, and this is a wavelength that is emitted preferentially by water vapor. Water vapor imagery is basically measuring the temperature at the top of the vapor layer in the atmosphere. So it doesn't mean that we're measuring the relative humidity or whether or not it is clear or cloudy. Now, if we have really high clouds, like we have here with Erin, the ice crystals in the clouds actually contaminate the vapor image. But if you take a look at the central part of the United States and you see this kind of milky gray and even this orange here, this is basically, again, using Wien's and Stefan Boltzmann to basically determine the amount of energy that is being emitted and then to use Stefan Boltzmann to calculate the temperature. All right, and so we can actually calculate the temperature of the top of the vapor layer. The top of the vapor layer is typically above the tops of the clouds. And so we can determine not how high the vapor layer is, but the temperature at the top of the vapor layer. And generally speaking, again, using this legend, which is in degrees Celsius, the whiter it is, the higher the top of the vapor layer is going to be. The lower it is, the warmer it's going to be. But you can see, if you take a look at these temperatures for the top of the vapor layer and you take a look at the warmest temperature, you can see it's only 0 degrees Celsius or 32 degrees Fahrenheit. So vapor is always going to be in the atmosphere, and we kind of know this, but it's really just trying to figure out where we get to the top of that vapor before the atmosphere completely dries out. Just going back one, if you take a look at the legend for infrared imagery, which actually measures all the way down to the surface, you can see that the warmest temperature is almost 45 degrees Celsius, which I believe is 113 degrees Fahrenheit. So again, the vapor imagery is taking a look at the top of the vapor layer, which is going to be well above the Earth's surface and much colder on the legend. All right, once we go through radar and satellite imagery, I'd like to take a look at some model numbers, just to give you an idea of what the models that we use to predict the weather are forecasting for the next 7 to 10 days. To do this, I go to the National Blend of Models text products. Here is the legend, or I shouldn't say the legend, the link right here on the right. And so typically what I do is under choosing products, I'll choose short, extended, and really extended. And then for choosing cycles, I'll choose the most recent. Now, when we take a look at the cycles, the NBM will only provide an update every 6 hours or so. So basically, I believe it's 1, 7, 13, and 19Z. But you can go up to this link right here in the yellow box, and you can get hourly updates there. So if you actually want to know what the models are doing on an hourly basis, you can go there. Now, what the National Blend does is it basically takes a composite forecast from roughly the 30 best models that are out there in terms of quality control to predict the weather. Some of these are global models, some of these are smaller scale mesoscale models, some of them predict over a very long time period, some of them predict over shorter time periods, and the reason that we get updates every hour is because some of these models do run every hour. There is data collection going on continuously, although the big data collections occur at 0 and 12Z. But there's always information coming from satellites. We get information that comes in from ship. We get information that comes in from jets that actually have instruments attached to them. And so there's always a dribble of data coming in, and buoys, by the way, as well, that is coming in continuously, although radio sondes in general are only sent up twice a day at 0 and 12Z. So what I do for our class, unless there's something really fascinating going on somewhere else in the country, is I choose our products, short, extended, and far extended, choose the most recent cycle, and then I'll put in the WMO stations manually. I'll type in KTOL for Toledo, and then I'll just actually click the view bulletins right here. So here's the next slide showing you short, extended, and X extended, which is another further couple of days out. Here's the latest for our cycle selected, and here's KTOL. Now the short range gives us a forecast for 2 or 3 days. The extended range will give us a forecast for 7 days, and then this X extended will actually give us a forecast going out to 8, 9, and 10 days. I can't show all of it here, but when I actually do our first real map discussion where I really am focused on the weather rather than just presenting a backgrounder for you, I'll try and show you all of these numbers. And this is what some of the output looks like. And I'm just showing you the extended here, the EXT. So here's our 7-day forecast. Our forecast hour, we only get 12 hourly forecasts, 0 and 12Z, 0, 12, 0, 12. Here's the forecast hour. And so you can see we're going 185 hours out into the future from this 7C forecast. Here are our max and min temperatures for each one of these 7 days. And here is our temperature at the actual time. So this is the temperature forecast at the exact time. Not the max and min, but the temperatures at 0 and 12Z for each of these days. Then here's our dew point temperature forecast for each of these times. Here's sky cover in percent, wind direction for each of these times, wind speed in knots for each of these times, and the gusts. Wind direction, by the way, compass direction, this is 2 is a 20, 20 degrees, 30 degrees, 20 degrees. So basically, wind direction is pretty much out of the northeast for almost all of this. Probability of precipitation from 0 to 100. So you can see it's a dry forecast. Again, very boring for Bowling Green. Quantity, Q of precipitation for each 12-hour period. This is in hundredths of an inch. So no precipitation at all forecast at all during the 7-day period. Q24 is just totaling up the 12 hourlies. Again, nothing. No duration of precipitation since nothing is forecast, and so on. And just, I'll show you one more. T12, this is the probability of a thunderstorm during each 12-hour period. And you can see that actually is forecasting a little bit of thunderstorm activity probability. It's still not going to happen, but just a little bit of a probability, basically late day Saturday and into Sunday morning. We have a cold front coming through during the weekend that's going to really knock our temperatures down. And by the way, I'm recording this video on the morning of the 22nd, and the NBM has actually cooled things down another degree or two for the end of the weekend, the beginning of next week. So we have a couple of really late summer, early autumn days coming up at the very, very beginning of the semester where our highs are going to struggle to get above 70s and our lows are actually going to get into the upper 40s. So it's going to feel, I think, for most of us really, really nice, particularly for anybody living on campus that doesn't have air conditioning. This is going to be really welcome weather. And finally, I actually do give a weather forecast from the National Weather Service. So here is the homepage for the National Weather Service, and here's the link. Here's a map of the United States. And again, if you took me for weather and climate, you know that these colors correspond to active watches and warnings across the United States. Here is the legend for all of these colors. Now, there used to be a lot of other information on the homepage about severe weather and hurricanes, drought, floods, and all of that. And the Weather Service took that out during the course of this year. They didn't get rid of it, but they made it harder to find. And now you can kind of go up a color about active alerts, forecast maps, forecast up here. So just know that if you're looking to actually get more information about a specific phenomenon or event like Hurricane Erin, you can still get to the National Hurricane Center, but you may have to go up to forecast here or active alerts to actually get to the Hurricane Center. I'll just say that the government's making it harder to find this information and leave it at that. But the information is there, so don't worry about the fact that it's disappeared. It has not. Now, one of the really nice things about the Weather Service is that you can get a forecast for any point across the United States, the lower 48 as well as Alaska and Hawaii. All you need to do is either type the name of the location, so the town name, or you can actually put in the zip code. So in the next screen, what you're going to see is I put in 40403, which is Bowling Green, Ohio. And then you can just click go, and you can get a point forecast for Bowling Green. Now, I actually did not put Bowling Green on the next screen because at the time that I actually got these maps, we were not getting any reports from Toledo Executive, which is the airport that actually presents data, real-time data for Bowling Green. So I went a little further north to Holland, which is where I live, and then I just basically got information from Toledo Express. And so you'll see that right here. So here is Holland, Ohio. I didn't actually do the point forecast up there, but it is Holland. And here's what we had at 9:52 a.m. So here's the 10 o'clock report from Toledo Express. It was overcast 67. Here is the forecast for the next 7 days. You can get more local weather. You can get a 3-day hourly history for Toledo Express. And by the way, I will show you eventually how it is that you can get 5-minute updates for Toledo Express. Every 5 minutes, an update from Toledo's ASOS. So there's a lot of information that can be gleaned from the Weather Service. It's an incredibly powerful site. It provides a tremendous amount of useful information. And so this is the last thing that I show when I'm giving a map discussion in the classroom. Now, again, we don't have a classroom here. This is a distance class. And so I'm not going to be presenting map discussions every day of the week or even twice a week. I will present probably once a week. I'll put together a PowerPoint, I'll record a YouTube, and then I'll upload it and share a link with you so you can see what I'm thinking about the weather at least once a week. I'm thinking off the top of my head here, certainly while the weather is boring, I'm thinking that I'll probably record these later in the week so you have a weekend forecast, so you know what's coming up for the upcoming weekend. And then if we begin to get interesting weather, then I'll record as we're leading up to an actual weather event. When I recorded in the spring, I recorded before snow events. We had a couple of ice storms in the early part of the semester. We had some severe weather during the latter part of the semester. So when the weather gets interesting, I will record leading up to that interesting weather. But if we have boring weather, my thought is I'll probably record these videos maybe on Fridays and upload them so you can get a forecast for the weekend coming up. But I think that's pretty much everything I want to say here. So I'm going to end this video now. I will upload it to YouTube, and I think you're going to get an announcement from me on Monday or Tuesday of next week, but very, very early into the semester. If you have any questions at all about my map discussion, about the links or the maps I'm showing, by all means, post something to the discussion board during the preview week, or feel free to ask me live during my office hours, which this semester are going to be Monday and Wednesday mornings from 8 to 9 a.m. Nice and early for everyone. If you don't know it yet, I am a morning person, and so my office hours are going to be in the morning. So that's it. That's all. I hope you enjoy these discussions, and again, you'll see an announcement when this is ready for you to view.